In today's session, we will be diving into the what and why of data modeling. Okay, we'll cover, as part of this, we'll cover the different types of data model, different types of data models, and we'll explore the various types of relationship, such as one-to-one relationship, one-to-many relationship, many-to-one relationship, many-to-many relationship, and also we'll understand how to implement the data model in Power BI. Okay. And also, we'll take a deep dive in how to effectively deal with many-to-many relationship. What are the various approaches that are available? Okay. So now the question is, okay, what is data modeling? First of all, okay, data modeling is a crucial step. You take any application development, any project, a software project. Okay, the data, you need to have a solid data model design should be there. Okay, should have a solid data model design should be in place. Without that, if you start develop your application or any application, any software, it will cause it will cause major rework later point in time. Okay, so hence make sure that you have the proper data model design is in place, and then proceed with the development part. Okay, it is very crucial because it helps improving the data quality, enhances the decision making, and provides a clear structure for the database design. See, we cannot store all the data in a single table. It's something like you keep all the in your kitchen, you keep all the items in a single container. So is it possible? Does it make sense? Right? Let's say you have wheat powder, and then you have chili powder, you have other masala. You open everything and you pour it everything, mix it everything in a single container. No, right? You keep logically different thing, right? So in different containers, you keep different items. Similarly, when it comes to data, the entire the organization's data, it is not wise to storing everything in a single table. Logically, we divide the data, or we decompose the tables and store it into more than one table. Okay, so it provides a clear structure for your database design. Okay, by defining the relationship between entities, we can gain insights from our data. There are different types of data model. Okay, so there are different types of that. I will discuss a little later. So we need to, the data model is somewhat similar to your roadmap or the architects, the building architect's blueprint. So without having a proper blueprint, if you start construct the house, what will happen? Later point in time, if you realize if it requires some changes to your the whole house structure, so it requires a major rework. Even for making a small provision, you will have to that involves a lot of challenges in terms of getting the approval from your neighbor. Let's say you are living in a flat, not in a individual house, right? If you are living in a flat, then it requires a lot of rework. You need to get approval from the association member, and again you need to break the walls, neighbors wall also. It's all a lot of problem, right? So hence have a proper blueprint in place first before constructing the house, and then only we go ahead and proceed with the constructing the houses. Similarly, when it comes to any application development, make sure that you need to have the proper data model design in place. Okay, and then you need to as part of the data model, we identify the essential entities that are involved, business entities that are involved. Okay, for example, the customers purchase orders, what relationship exists between these two tables. A single customer may order more than one, may raise more than one order. Okay, and each order can contain one or more product, right? So there exists a relationship between the customer and orders, and there is a relationship between orders and products, and vice versa. And products and categories also, it has some relationship, because each category can have more than one product, and each order can have more than one product, and each order can have one or more customers. Okay, sorry, each order, sorry, a single customer can raise multiple orders. Okay, something like that. So one-to-many relationship, something like that. So you need to define the relationship, understand the relationship, and how the entities are nothing but tables. See, the term entity is related to table. This is, this is what the term they use it in the real world scenario. Okay. No, but don't get confused when somebody use the term entity and table. Both of them are same. Okay, the real world entities. These are the real world entities. At least in the case of retail store. Okay, customers raises orders, and each order should have at least one products in it. One or more products, right? But at least you should have one product in it. Without a product, how can you say it is an order, right? And each category will have more than one product. Some category, not necessarily, each category should have more than one product. There are some categories you have only one product. Let's say recently you launched a new product. That product, you started recently in your company. That is falling under a new category. So in that case, sometimes a category can have a single product only. But over a period of time, each category can have, in general, each category will have more than one product. So this is how the relationships are, we are able to understand how the entities are interacting with each other. So that is what we define it as part of the relationship, okay, data model relationship. And there are different types of data models. So, instead of saying types of data model, different phases of data model, the software development life cycle, isn't it? So the probably you can do Googling. Okay, the software development life cycle, SDLC, they say SDLC, software development, but the first phase of the software, for example, let's say in your company, you got assigned to a very new project. Okay, this project needs to be developed from the ground up. The first phase is your requirement phase. The requirement phase, someone from your team will talk to the customer, understand their pain points, and what requirements when it comes to reports. What are the reports that needs to be developed? What dashboards that they expect us, and how they impact their day-to-day activities, or how that impacts their business impacts. Okay, in terms of dollar when it comes to the business, right? So, for example, there are some dashboards are very, very critical. Okay, the CEO level or these C-level executives, they want some important KPIs to be seen at least every once in a week. They want to review that, based on which they may have to take some course correction then and there. If there is a delay in getting the report or dashboard to view the important KPIs, it can have some kind of impact on their business in terms of dollar. Okay, it's something like the hospital, the doctors should know the vital parameters of the patients, those got admitted under them every now and then. In case something goes wrong, importantly the critical patients, okay, if something goes wrong, they should be alerted, right? So, and they should, if they see, okay, the patient's heart rate is in danger zone, the blood pressure is in the danger zone. What that is, as soon as they get to know that, they take the course correction immediately. Hey, the patient's BP is very high. So now something, they call it as a labile blood pressure. Okay. Sometimes it will be very high, sometimes it will be very less. It will not be same, it will not be same throughout the day. This is very dangerous one, the labile blood pressure. Okay. So let's say if you take a patient in the morning time, the blood pressure will be normal. That doesn't mean patient is normal. Evening time, her blood pressure may shoot up, right? So, and if you come up with one size fits all approach, hey, this is the prescription, patient is normal, get her discharged. But evening time, and by the time reaches the one, but her she has labile blood pressure, which is a very dangerous one. Evening, suddenly it will pick up. So these are the vital parameters. They need to monitor it sometimes in real time. In the case of critical patients, this is a classic example. And then other instances are like the intraday trading, stock market. Right, so intraday trading, you are buying the equities in bulks, or you are pouring money like anything. Okay, let's say you buy 1,000 equities. okay, or 10,000 equities. And you need to, even if there is a mild, the margin, if the margin goes even little bit less, it will have a serious impact because you bought everything in bulk. So, right. So in that case, right, you need to know, what kind of action that needs to be taken then and there. So there are, in that case, right, as part of the requirement phase, you understand their reporting requirements. Is this a real-time dashboard? Which means as and when the data comes in the source system, it should be sensors. They use sensors. Okay, this the classic example is the patient's blood, and the manufacturing unit, right? They use sensors, and right. So during the manufacturing process itself, the sensors keep sending the data to the system, and with that, you may have to take some decisions instantly. Okay, stop the production if something is not as per the specifications. You need to stop the manufacturing everything. So as per the requirements, you understand the different requirements from various departments. Okay, and then what you do is, you find out, what are the report that needs to be created, what are the data dashboard that needs to be created, and to create those dashboard and reports, what are the tables, important tables, and for the overall aspect, each line of business, they call it as a line of business. Each department they call it a line of business. In the marketing line of business, in the finance line of business department, okay, finance department, marketing department, costing department. So what kind of purchase department? Okay, so each department, they will come up with a comprehensive data model. So it should cover all the tables, the major tables, important tables, everything. And then you need to define at a high level how these entities are interacting with each other. Look, your product is have an interaction with sales, right? How many products you sold? You never say, this is my total sales all the time. So you want to see the breakup of the sales by product, by category, by store, by time. So you need all these entities. So after speaking to, you conduct workshop with the each department manager or the key stakeholders, and then you come up with this model. Okay, this is called your the conceptual data model. Okay, in the case of conceptual model, it's a big picture. Okay, here you understand or the conceptual representation of the data structures, relationships, constraints in a domain. Okay, it helps us to organize and make sense of our data. Okay, that is what you do it as a conceptual data model. This is what I explained. This is kind of your conceptual data model, how the data flows from one entity to other entity and all, right? You just define it. And then once you are done, based on your understanding, you define everything, and then you share it with the stakeholders for their buy-in. Buy-in in the sense their agreement. Okay. Once they review it, hey, yeah, this is correct, this is correct. Probably you can include one more table. We need a region dimension because we want to see the sales breakdown by region. So include the region table also along with this. And they give some feedback based on which you modify the existing one. And then again, you get there. Again, you need to vet it with the stakeholders. Once they sign off, and then you go to the next phase, that is called your logical data model. So what is logical data model? The logical data model is your, it is extension of your data model. It is, sorry, the conceptual data model. The logical data model is an extension to your conceptual data model. So in this case, you go one step further. Identifying the table names and entities alone not sufficient. So each table should contain what information in it. What are the columns that are required? Columns are also called as attributes. I just write it, attributes. Attributes are called your columns. Okay, each column is called attributes. Okay, so they use different terms. This is from the data modelers, data architect. They use term. Entity. Entity is nothing but tables. Attributes are nothing but columns. Okay, so as for logical data modeling, you go one step further and define what the columns that are required as part of each table. Right? And then you define the relationship clearly here. So one-to-many, is this a one-to-many relationship? Is this a many-to-many relationship? Or is a many-to-one relationship? Something like that. right? So that is what you'll be defining it as part of the logical data model. This we will see it in detail when I create the data model design. And the final one is the physical data model. The final phase is the physical data modeling. The physical data modeling, they go one step further. And then what they do is, okay, date ID is required, date this is what data type is that? And what is the width of each column? For example, product description, it should allow us to store 50 liters in it, okay? It should allow us to store up to 50 characters in it. Okay, so the data type and width is also important. Okay, so that is what we define it as for the physical data modeling. Initially, come up with some kind of big picture. What are the entities that are required? And then you talk to the customer and you share the design. And if they find any, anything missing, they will get back to you. So after, amending your uh, conceptual data model, you share it with them and you vet it with them. Once they say go ahead, logically, each phase we do design everything and we share it with customer, get their buy-in. Once they say, hey, everything looks good, go ahead with physical data modeling. So here also you do data type, you define the data type. So here the logical data modeling, we just come up with the list of columns for each table and then the relationship, one to many, or that we define it here. But in the case of physical data model, we go one step further and define the data type and the width of each column. That's all. Hope you understood, the different phases of data model. Instead of saying types, right, probably I need to change it. The shapes of data model. Okay, different phases of data model. So the conceptual data model, and then the logical data model and physical data model. And yeah, so there is a question from Soumya. So is there anything like types of data model? Yes, we have something called hierarchical data model, network data model. So these are all very older one. Okay, the hierarchical data model in the olden days they were using hierarchical data model, network model. Now the relational model gained popularity. And apart from this, we have something else called object-oriented data models. But we will focus on the relational model only because this is the one is widely used. Hope you understood. Sorry, Soundarya, correct. Next one is the next question is why we need to define the data model first of all. And let's say you worked on a Tableau or ClickSense, but there we did not do any data model design. All we did was we just loaded all the connected to the various source system. For example, SQL Server, Oracle, or the XML file, the HTML file, or Excel file. That's all. We never did data model design there. But when it comes to Power BI, it is mandatory that you have to do the data model design. But you don't have to define the relationship between the tables explicitly. It is detected automatically by the Power Pivot component of your Power BI desktop. But you can do the data model design only in Power BI desktop. You cannot do it on cloud. The Power BI cloud service, you cannot do that. This is the one you need to know that. Okay. So the next question is why should I do the data model? How it is going to help me? I'll just show you with an example. Without data model, it is not doing the filtering. It will not do the filtering. For example, I just go and connect to we'll start with some text file that is enough. The text sales fact. Now I'm going to load another file here. Let's say dim location. See, remember one thing. There are some students, they raised some, they forced some issue. When they load .xls file, they were getting some error. Okay, in that case, what you do is you click on the Excel file, open it, and save it as .xlsx. Okay, because there are some releases of Power BI Desktop. It works only with the XLSX version. Okay, the latest version of the Excel file. So I'm going to load another file, and here I'm going to rename it. 1 second. Here it requires some kind of transformation. Okay, I just I'll go to the transform ribbon, and then I'm going to promote the first row as a column. Location key and location name. And the NC sales, I just rename it as some sales fact. Okay, this looks good. And location key and location key only I'm going to join it. Hence, you don't have to do any more thing. And I'm going to load another file also, one more file. Customer dimension. That's all. We loaded these files. Let's do one thing. We will use the table visual. I just clicked on the table visual here. The moment you click on the table, look here, this is called your table visual. It is available under your visualization pane. The next thing is I just go here and then I'll drop a location name in this table, and followed by that I just drop the sales amount. The sales amount and location name, these two columns are available in two different tables. Okay, but if you see here, yeah, the location name came from your location dimension. The sales amount column came from your sales fact. But if you see here, the column name was sales amount. But the moment when I dropped it here, it became automatically sum of sales amount. With this, what we can understand is, though the column sales amount, though the column name is sales amount, when I drop it here, what it does is it performs aggregation. It finds out the total sales made in each city it shows. Forget about the blank one, the location. There is some problem here. There are some missing values are there. Okay, forget about the first value. The rest of them you can see that here, right? So the Bangalore, it gives me the breakdown of sales across different cities. Breakdown of total sales across all the cities. Okay, that is possible because of the relationship. See, in this case, I don't know how many of you noticed. For example, I just click on the table visual. When I drop the sales amount column alone here, it shows 4,56,000. Gives me only one number, which means it did the total on the entire sales amount columns value, 4,56,000. Only one value it gave. But along with this, when I dropped a text column location name from the location dimension, it gives me automatically the breakdown of sales amount by location. That is the beauty of Power BI. So how it is giving me the breakdown of the sales amount by location automatically, that is possible because of the relationship between the tables. I just go here, and then if I remove the relationship between these two tables, it will not work. So end of the day, the location dimension table is able to filter the fact dimension, sales fact table with the relationship. Without the relationship, how it can do the filtering? Look here, the total sales value got displayed across the rows. Since I removed the relationship, it is not doing the filtering correctly. It is not doing the filtering correctly. To explain this simply, I will just open the Excel file here, or I will just write it here somewhere. But instead, we will use some Excel file. So it is doing the filtering. This is very important. Please try to understand. And even I could see that, there are guys, they say they work in project, all the things, they know why they need to do create. What is filtering? When I ask them, they get stuck. How it is filtering all the things. Salesfact.xls, I'm going to open this. This is the file that I used it here. I loaded it here. Here, in this case, the first one is related to Bangalore. I will just increase the font size so that you all can view it clearly. Font size, the global font size is, let's see. So in this case, I go to the, right? So this is your location dimension. This is your sales factor. This is the one I'm opening it physically here in the Excel file. And it takes time. I think there are some issues here. So this is your sales factor XLS. So what happens is you have another Excel file that is your what? That is your location dimension. What happens is in that location dimension Excel set, let's say the first record was Bangalore. Okay, Bangalore. So since you have, let's say you create a relationship between these tables. I just drag and drop the location key on top of the location key of this sales fact table. Make sure that to create the relationship between the tables, you need to identify the common column between the tables. With that only you can create the relationship. And also make sure that you drag and drop the common column and then drop it on top of the same column in another table. So either you can drag and drop it, or you can drag and drop it this way also. It is fine. But it detects the relationship automatically. Look here, it's a one-to-many relationship, which means for each location, only one unique location key will be there. This is the primary key. But in this case, this is a foreign key. It is not a primary key. Okay, foreign key column can have duplicates, whereas primary key column should not have the duplicate column. For example, your location key is BLR. BLR should appear only one time in the location dimension table. BLR is Bangalore, short form. Okay, look here. So what happens is, this I'm going to keep it here. Yeah, instead of seeing this way, this is better, right? Manage relationship. Yeah, manage relationship. Click on it. And then if you edit this, you will get a clear understanding. Instead of using Excel, look here. So in this case, the sales fact table and then location dimension table. So these two table, if you see the location key column, this one got grayed. gray color, right? That means, the common column between these two tables got identified automatically by the Power BI desktop. And it's, since the common column is location key got highlighted. And also, these two columns we use to create the relationship between the tables. Okay, that is the one, right? We are able to do the relationship. But if you see cardinality many to one and cross filter direction, okay, and that is what we can see it here. Okay, so in this case, what happened? The first record in your location dimension location is BLR. So what happens is, what do you mean by filtering? Okay, the first record in the dim location as BLR in the location key column, and then location name was Bangalore. Since you have created a relationship, look here, if you keep the cursor, hover the cursor on top of this line, in both the table, the location key column got highlighted. Which means using location dimension table, the location key column, you can filter your sales fact tables, location key column. So what happens? The first record, Bangalore BLR, that key, right? Location key will be sent here. The moment when it receives the Bangalore key, all the Bangalore related transactions are grouped. All the Bangalore related transactions are grouped. Where is that thing? Here what happens, all the Bangalore related records get filtered and then it applies sum on the sales amount. So if you apply the sum, what will happen? Sorry. See here. So the sum is 5532. 5532, right? 5532 in Bangalore, 5532. And once the total sum is computed, it will display only when BLR 5532.4, right? For input 4. And then it goes to the next record in your location dimension table, wherein let's say you have some Pune is there. So what will happen is it will clear everything and then it will automatically apply a filter on the Pune location. So all the Pune transactions are there. It applies the sum on this sales amount for Pune location. Okay. What is the sum here for this one in Pune? The sum is 5493, 5493, something like that. And similarly, if you select Kolkata or somewhere, okay, and what is the 1694 total sales. So what happens is it sends the keys one after the other, the keys, right? First to Bangalore, and it group all the Bangalore related transactions. It applies the sum on the sales automatically. It's all happening automatically. Okay, Bangalore 5532 and Chennai, what are the total sales? Okay, and then see in this case the location dimension, it goes to second record, or the third record where Chennai is there. CHN key will be sent here. All the CHN related records will get grouped, and then it applies the sum on the sales amount column. But if I remove the relationship, it is repeating the same value, the total sales across the cities. That is not the expected one. Each city, can you say the same 4,56,000 sales happen? No, right? Each city, how much total sales we made, that breakdown is given automatic. That is because of the relationship that we defined between the tables. Without relationship, this is not possible. But this is the relationship also detected automatically. You don't have to create it explicitly. It detects automatically, and it makes our life simple. But this is possible. Here, I did not write any formula, any DAX queries. It gives me the breakdown automatically. So now you understood with this example why data modeling is important in Power BI. In Power BI, you have to define the data model design explicitly. But Power BI, once as and when you load the table data or something, right, it automatically detects the relationship. But still, you need to go and verify it, validate it. Sometimes what will happen is here they use a location key, here they use the location ID. As a the data application data owner, here the location key and here the location ID is same. If it is a location ID, the column name is location ID here instead of location key, and here the location key column is there. what you need to, either you rename it as location key here, or you rename it as a location ID, so that let's say you have location ID, location, both of them, both the name will be in the same standard, right? Coding standard name. Okay. So the column naming should be, same. But before you rename a column, make sure that both of them having the similar kind of data. Okay. Fine. You got it. We have something called artificial key and then the business key. Okay. That we'll discuss it later. So at this moment, you remember that if the column names are, if you have a common column exists between the two tables, you can create the relationship, common column. But that doesn't mean location key and same name for example, you have the location key. In this case, it has some space in it. Okay, I just press enter. Here the space is there, but whereas space is not there. Okay, now let us do one thing. If you have space here, it will consider a different column. This one will be considered a different column. Or instead of this, location ID is there. Okay. So in that case, physically you can go and check, verify whether the relation. If you don't find a relationship, that doesn't mean there is no common column. Maybe some naming convention issues. Here they specify the location key together, but here location space key they've given. Either you can rename it with the proper naming convention. And here itself we can do that. The location key, you go here and remove the space and press enter. Location key and location key. Okay, you get it. And then it'll once you make the naming, right? Common name in terms of the the proper name, right? The location key, no space, nothing. So in that case, it detects the relationship automatically. Okay. So why data modeling is required? To do the filtering. To do the filtering correctly, we need a data model. Without that, the entire total sales will get displayed across the cities. That is not the correct one. The slicing and dicing will not be done automatically. Okay, the slicing and dicing will not be done automatically. What is slicing and dicing? I don't say all the time, I don't want to see all the cities' sales performance. I want to slice my data. I want to cut my data to view only specific cities. Bangalore and Chennai alone, I want to see the data. Okay, what is slicing is a specific portion of the data you want to see. What is dicing? The specific portion with respect to the measures, right? If you want to compute the total or something like that. So that is what is called dicing. Okay, slicing and dicing will not happen if you don't create the relationship between the tables. Hence, creating relationship is very much important. It could be either the automatic, table design or automatically detects the relationship. But for that, the column names should be same. But there are cases it will not be same all the time. But as a business owner, application owner, this column is nothing but this one. So in this table, location ID is there, and in that table, location key is there. Both of them contain the same values only. Hence, I'm going to drag and drop it. So explicitly, in that kind of situation, you need to create the relationship between the tables in that kind of situation. If the column names are not same, but the data are same in both the tables column, in that case, you have to create the relationship explicitly. Next one is the filtering. What is filtering? That's what I explained you. So let's say you have the location dimension. This is your dim location, dimension location. This is what your sales fact table. Since you have created a relationship between country ID and country ID, this is one side, this is many side. The US appears only one time, AU appears only one time. All the ID key column, or we say key column, country key or country key, all the values are unique here, but whereas here the same country key column as the duplicates, US appears more than one time, but whereas here US appears only one time. Hence it is a one side, it is a many side. So since we have created a relationship, between country key and country key column in both the table, what happens is behind the scene. And the US first, it goes the first record, the US, the country ID, because we have created the relationship based on the country key only, right? If country key US will be sent here, this one will be sent to this table. But in the sense, right, using this value, it is going to filter this table. Hey, you select only the US related records. How many US related records are there? 1, 2, 3, 4. Group all the US related records. We can say that way, okay? And then you apply the sum function, sum of sales, sum of quantity. Once it has been done, you will have only one record. In US, let's say the total sales is, look here, the quantity, okay? 15, 17. Let's take quantity because it's easy for you to make out, right? This is your country name, collection of country, and quantity is 17. And then it goes to the next record, Australia. It groups all the Australia records. And in this case, we are focusing only on quantity. So 10 plus 5 is 15 in EU. Australia 15 is there. And US 17 is there. And Germany, you have 80 is there. GE, Germany. Understood? This is how it does the filtering. If I use the term or somebody using the term filtering, you should understand this is what is happening behind the screen. This is what he's talking. Filtering is also called as a relationship. So once you create the relationship, does the filtering automatically. Filtering and relationship, both of them are same in the case of Power BI. Okay. So this is a typical data modeling process flow. We can skip that one, but because it is not, probably you can, we will see that this is already discussed, right? As for a conceptual data model, we identify all the major entities, the tables, and each table, what are the, key property, what are the columns or attributes that are required, that you identify, and then identify the relationship between the tables or the entities or among the entities. The next one is map attributes to entities completely, and then logical data model, and then you visualize the data. In case of the filtering is not happening due to some reasons, all right, so you need to assign some keys and then proceed with determining the degree of denormalization. And then what you do is, in this case, denormalization, okay, because we are talking about the star schema, snowflake schema. And finally, vet it with your stakeholders. And you share the document and everything is correct. This is what our understanding. Please review it and give us your approval. When they review it, if they find something missing, they will come back to you. Include that one. And again, you resend the document. Once they find it good, it covers everything, then they will do sign off, and then you proceed with your report development or ETL process, everything. Okay. Next one is we will understand something called star schema and snowflake schema. What is star schema? So there are two types of data modeling. One is the normalization. Other one is denormalization. Okay, as for the denormalization, this is nothing but dimensional data modeling. Dimensional data modeling. Okay, in the case of normalization, also we do the data model design, but that is not like your dimensional data model design. Okay, dimensional data model design. So this is in the case of OLTP, online transaction processing. We follow this data model type, the normalization. Okay, and in the case of OLAP, online analytical processing, which means analytical projects, we do the denormalization. So what is denormalization? What is normalization? See, in the case of denormalization, what happens? See, this is your OLTP system. This is where all your orders, the customer's orders are stored here, right? In this case, what happens? Like, the customer information itself, customer table, customer master table, and then address table. Okay. To store customer related information, they store it in two different tables. The same table will get combined together into and then it make it as a single file. That is called your customer dimension table or dim customer. In this case, we are combining more than one table and then making it a single table. This is what called as denormalization, at a high level. Okay, this is how it works. But in the case of source system, the tables, the data for the customer is not available in a single table itself. So it is available in some cases more than two tables also, more than one table, more than two tables also possible. In that case, identify what are the tables that you need to use it in order to do the denormalization. Okay, that you need to do it. And then denormalization is nothing but combining multiple tables, multiple relevant tables into single table. In this case, the example is customer name, first name, last name, customer date of birth, and all the informations are there. The address, and then you have some kind of address key here, and the address key, the address table will hold the address key and the address name. Okay, that is what the information is. So what you do is you try to store both of them in a single table so that you don't have to join multiple tables. Joining multiple tables will slow down the performance. That is the reason why in the case of OLAP system, the data warehouse side, they do the denormalization. So if you store these two information in a single table, it doesn't require a join operation. It doesn't need to do something. You don't have to do any joining. Okay. Since it's all available in a single table, the performance will be faster. Okay. So in the case of denormalization, it is also called the dimensional data modeling. Okay, there are two types of dimensional modeling. One is the star schema, and then the other one is snowflake schema. Snowflake schema. Okay. Star schema and snowflake schema. Now let us look at what is star schema. This is the example for this. A single fact table. Let's say in this case the sales fact table. The sales fact table is surrounded by multiple dimension table. Customer dim and product dim, date dimension, sales territory dimension. Reseller is a fact table. Reseller another fact table. Okay. If you see this sales fact table is surrounded by multiple dimension tables. Hence, it is called star schema. Since it is surrounded by multiple dimensions, it looks like a star. Hence, they call this one as a star schema. Now you understood what is normalization at a high level. In the case of normalization, what they do is they decompose, which means they split the tables into multiple tables. The classic example, customer master table, then address table. The customer master table, what will the customer ID, customer first name, last name, and date of birth, and active since, okay? From which date you onboarded him, how long, yeah, so only when you know that, you will get to know how long each customers are making purchase from us, okay? And then we have some other column called status, whether the customer is active or inactive. Okay, so that information, but address detail will be stored on another table. Okay, so in that case, in your customer table, you will use something like address ID. With that address ID, you will be joining with address table to get the complete address. Why they store the data in multiple tables in the case of OLTP, same customer table, why they have to store it in two different tables? Because of performance. If you store huge volume of data in a table, it literally slow down. Because in the case of Walmart and other things, right, across the globe, every 1 hour on an average, 1 million transactions are happening. So in that case, the data retrieval time should be pretty faster. If you want to buy a specific, if you want to buy a hair dryer and you want to see the price for a specific brand, it should display it instantly. If it takes more time, what will happen? This website is not helpful, man. Better we'll go to some other website. You're going to lose the customer. To improve the performance, they splitted the data of the customer into more than one table in this case. Okay. So in that case, what will happen is, since each table has less number of data in it, the performance is pretty faster. For that reason, they did it. This is to cater to the online transaction. They came up with a concept called normalization, or modeling technique called normalization. They decompose, which means they split the single table data into more than one. They store the single table in more than one table logically. Okay, so that, that's how they do it. Okay, like a customer master table, address table. Okay, and the next one is, in the case of denormalization. Denormalization, we do it as per data warehouse or OLAP. And why do we need to do that? Because joins are very expensive. And remember that in the case of data warehouse, we store huge volume of data, historical data. So in that kind of situation, if you join the tables, any join, if you perform, it will literally slow down the performance. Instead, what you do is customer and address table is stored in a single table, so that it doesn't require any kind of joining. For that is called a denormalization. As part of this, they combine flattened the master tables, the source system tables in a single table. Next one is the dimensional data modeling. As for denormalization, there are two techniques, star and snowflake. Star, I explained you. The fact table is surrounded by more than one dimension table. And each dimension table's key column flows from your dimension table to your fact table. Look here, I just got the power model view. Look here, in this case, the location dimension. Where is the customer dimension? It is there here. I just move this somewhere here. First, we will organize it. Once you load the data, let us organize the dimension tables. All the dimension tables should get displayed on top of the fact table, but this is nowhere going to do anything with your data transformation. But this is for our understanding. Okay, keep all the dimension tables at the top, the fact tables at the bottom. Usually the fact tables if you go to any project, right, maybe one or two or maximum two or three fact tables will be there. That's all, not many. But dimension tables are more. You need to remember this. Okay, and here there is some there is some problem here with respect to the thing. The customer dimension chose column 1, column 2 instead of displaying the original column. We need to promote the first row as a column here. Look here, customer dimension location. In this case, I addressed it customer dimension table. Look here, column 1, column 2. The first row we need to promote as a column. Just go to the transform, use first row as it is. First row is custody, first name, and this one will become, we are done with that. Look here, automatically creates the relationship because the custody and custody, both the column names are same. Hence, it created the one-to-many relationship between the customer dimension table to sales fact table. Again, we can see that on the next to the customer dimension, one is there. Next to the sales fact, we can see star. So many, this is one-to-many relationship. This is called one-to-many relationship. And let me do one thing. In this case, this is your fact table. It is surrounded by your dimension table. Hence, it is called your star schema. Now the question is, what is a fact table? What is a dimension table? The fact table, I'll just write it. The fact table consists of the keys. Sorry, the fact table consists of keys from various dimension table plus the measures. Key plus measures. Some keys from various dimension tables. For example, the location key, location key is there and location key is there here. So the fact table, in the interview when they ask you, can you tell me what is the fact table? Fact table consists of the keys from all the dimension tables. For example, location key, location key. The fact table consists of the dimension tables location key here in this case. And custody is also there here, right? All the dimension tables, key columns, plus the measures. Measures are nothing but the numeric values, the discount and list price, sales amount, quantity. These are called your measures. Okay. The keys plus the fact table consists of all the dimension tables, key columns, plus the measures. What is measure? Measures are numerical value. You just tell them that way. Okay. Fine. What is dimension table? Next interview question. What is a dimension table? Dimension table contains the primary key column, and also it gives the descriptive information about your facts. Facts and measures are same. The fact and measures are nothing but numerical values in your fact table. And that's what the dimension table consists of: the key, primary key, and descriptive information about measures. Sorry, measures. Descriptive information about, yeah. So the dimension table consists of this is your primary key column, customer ID. The rest of the columns are non-key column, but the rest of the columns gives additional context about your measure. What do you mean by additional context about the measure? In your fact table, let's say you have a quantity column is there. In the quantity column, you can see the 8 is there. Okay, in the quantity column, I have something called 8. With that itself, can you understand what is happening here? But you need to know, right? So what is quantity? The quantity 8. You are saying 8 quantities. What is this? What are these 8 quantities? In which product is this related to? How many number of products purchased by the customers in all the transaction, or is it something else? Okay. So in that case, to give the additional information, quantity, we sold 8 quantity in Bangalore location for a specific product. We were able to sell only 8 products. So with Bangalore, additional information, location name is Bangalore. It gives a context to your measure quantity. Bangalore location, how many units we sold? Okay, oh, this is what in Bangalore location, or we sold 8 quantities or units. If you simply say the quantity is 100, 10, 12,000, what is this all about? I know quantity, fine. What is quantity? I know that. I know English, but give me some additional information. Yes, this is Bangalore sales. How many have been Bangalore? We were able to sell only 8 cars. Oh, okay, now I understood. Okay. Or if, let's say you say in Bangalore, we sold 8 quantities, and these 8 quantities were bought by 3 customers. Who are all the customers? That details are there here. John, Joseph, and Chris. These 3 guys, they bought 8 cars. Out of this, which can you tell me how many cars won by each car? That's a different question altogether. So our focus is now is to understand what is dimension table. Dimension table gives the descriptive information about the measures. That's all, guys. So the fact table consists of the combination of all the dimension tables, keys plus the measures. Measures are nothing but facts. Facts and measures are also used interchangeably, which is nothing but the numeric values. Okay, that's all, guys. This is called your star schema. Now you understood what is a dimension table, what is a fact table, what is one-to-many relationship. And there are different types of relationships are there. The one-to-one relationship and one-to-many relationship. Look here, in this case, one-to-one relationship, right? One-to-one sales order and sales table as one-to-one relationship. There are some cases also you will have one-to-one relationship. For example, the classic example is Aadhaar key. Other number, right? Other number. Let's say 101. This is for the citizen name is Ashok. Okay, and for example, you have another other number 102. That is for John. So here there exists a one-to-one relation between these two tables. Okay, so each other number should be assigned to a single citizen. Each citizen should have only one other number. It is called, this is an example for one-to-one relationship. And what is one-to-many relationship? Give me some example. What is one-to-many relationship? In a single company, one-to-many relationship. In a single company, more than one employees are working. This is an example for one-to-many. A single company employs multiple employees. And many-to-many, give me an example, many-to-one. Multiple products ordered in a single, the order, okay, in a single order. So multiple products purchased in a single order. Okay, this is an example for many-to-one. And one-to-one, one-to-many, many-to-one, we have something called many-to-many. This is, the one is little bit tricky. Sorry, many-to-many relationship. What is many-to-many relationship? Give me an example for many-to-many relationship. What is it? Each row in a column, or each row in a table is associated with multiple rows in other table. The classic example is customer or employee and project. Employee ID is let's say 10001. Each single employee can work on project 1, project 2. A single employee can work on multiple projects, and each project will have multiple employees. Each employee can work on multiple projects, and each project can will have multiple employees. This is the classic example for many-to-many relationship. What other examples? Any other examples for many-to-many relationship? Any other example is something like the customer and product. Okay, as P1, P2, P3. A single customer orders multiple products, and each product is ordered by more than one customer. So each value in a table is associated with each row in a table is associated with multiple rows in other table. Okay, that is what is called your many-to-many relationship. This is a little bit tricky to implement. That you need to use a different strategy that we'll discuss a little later. First, to summarize the star schema. In the case of star schema, the fact tables keeps all numeric values along with the key values, right? The dimension tables, key columns, dimension dimension tables keys along with the numeric values will be there in your fact table. And the dimension table consists of all the descriptive information and the primary key. It is also called a surrogate key into other tables called dimension tables. Fact tables are surrounded by the dimension tables that explain those facts. For example, like I mentioned earlier, the customer dimension, it explained me 8 quantities purchased by each and every customer. And okay, tell me how many products purchased, how many products purchased. So in that case, product table is helpful. Okay, product dimension table. So the dimension table gives the descriptive information about the facts in the fact table. Next one is snowflake schema. It is an extension of your star schema. So even in this case, if you see the fact table, right, is surrounded by the dimension tables, but in this case, the dimension table itself surrounded by other dimension tables. It's kind of hierarchical structure, right? We can see within the dimension table itself, we can see some kind of hierarchy, right? So in this case, the single dimension table, it's got splitted into more than one dimension tables. And importantly, when you notice this location and dimension table, sorry, the country dimension table, these two are not directly linked with your fact table. If, for example, if your manager wants to see the total revenue by region, this table needs to navigate via this table to reach the total sales for each region. Okay, this table is not directly connected here, but whereas this table is connected directly here, and these two tables were directly connected here. If you want the location dimension table to filter your fact table, it has to navigate via this table. Otherwise, because there is no direct connection, indirectly only has to go and get the information here. This is called your hierarchy, right? So this hierarchy. So in the case of dimensions, the dimensions are usually representing hierarchies. In the case of Snowflake, and the advantage of Snowflake schema is it uses smaller displays. You will not have the redundancy. Okay, so that for that reason, the split and storing more than one table. It is easy to implement dimension because of multiple tables. For example, the single dimension, you can store all this in a single dimension table, isn't it? So why we need to store it? Because of it consumes lesser disk space. For that purpose, we are splitting it. But if somebody is asking, give me the sales breakdown by location or revenue breakdown by location. So can this table filter this one? No, this table has to filter this table via this table. Okay, can this table filter? Yes, that is possible. The brand dimension and product dimension can filter the fact table directly. But if this table needs to filter this table, you need to join this table with this table, and this table needs to be joined with, and it requires multiple joins. Hence, your reporting performance will go down. Now you are in a dilemma. You are saying, in the width of Snowflake schema, it uses lesser small disk space, but the report performance is less. Which one should I go about it? Okay, it all depends on your project and requirement customers. Okay, the customer says there are some projects they mandated us, you need to use this data model design only. So right, we have to go literally what, but still we can go ahead and explain them what is the impact. If we wanted to see the breakdown of revenue by location, we need to join these tables because these two are having huge volume of data in it. You just think that way. Okay, hence you need to join this table, then you need to join this table. It's a roundabout way of doing the filtering. In that case, it will literally slow down the performance. The best thing is you can combine also. Even Microsoft, what they recommend is denormalize the tables. Create that star schema design so that all these 3-dimension data will get stored in a single table. That way, we can avoid creating the relationship between the dimension tables. Okay, so there are some advantages. The disadvantage is also there, but nowadays we are dealing with huge volume of the data. And if you see here, if you join with more than one table, slow down the performance. Better you can store it on a single table. Nowadays, the hard disk the cost of hard disk is very cheaper. Storage, storing huge volume doesn't matter, right? But only thing is the CPU, the processing, should be pretty faster. So best you can do the star schema design. That is what recommended by Microsoft. Wherever it is possible, use star schema. Star schema. Don't use Snowflake schema. So what is fact table? We already discussed. It contains the measures, something like unit cost, sales revenue, profit units sold. The data in a fact table should be sliced and diced by the data of dimension. With the help of the dimension table, we can slice and dice the measures in your fact table. For example, if somebody is asking you, can you give me the region-wise? Territory is kind of a region, okay? Region-wise sales breakdown by product, by customer, by quarter. With the help of the dimension table, we can slice this fact table data and then we can dice it. Slicing and dicing is possible. Next one is what are the different types of fact table? The transactional fact table. Every day, whatever the transaction, that one will be uh, pushed to this table. And then periodic snapshot fact table. Every once in a month, monthly sales performance or monthly performance, they want to say. So every month, you create another fact table. That one will a monthly fact table. Okay. So in that case, every month accumulated the summarized data will get stored there. And accumulating snapshot fact table. Accumulating is kind of the same thing. Okay, yeah, 1 month, month one, month two, something like that, and then you combine all the things in a single fact table. And apart from this, we have the aggregation fact table. Okay, it stores only the aggregated data there. Okay, but in that case, that aggregated fact table volume of data is less compared to the transactional fact table. Next one is factless fact table, that is called your bridge table. That we'll discuss it later. This is this is what your this is what an example for factless fact table. In this case, each salesperson work across more than one region, and each region has more than one salesperson is there. Hence, it is a many-to-many relationship. In this case, what we do is we need to create a bridge table. This is called your factless fact table. Okay. In this case, what you do is put the key column from both the tables. So these two are coming from two different tables, but you combine it in a single table. Is called your bridge table. It is also called a factless fact table. Why it is called factless fact? Because we don't have the fact here, only the dimension keys are there. What do you mean by fact? Like I said, the units sold, sales amount, net sales, net margin, these are your numeric values. The numeric values are nothing but facts. In this case, you don't have the facts in it. Hence, it is called a factless fact table. So, transactional fact table, periodic snapshot table, accumulating periodic snapshot table, and you have the the factless fact table and aggregated fact table. These are the different types of fact tables that are available. Okay, next one is, we already discussed about the relation active and inactive. What we will do is tomorrow we'll continue this one. Okay, I'm feeling a little bit tired, and we'll continue this one tomorrow. Probably we'll spend more time tomorrow. Okay, so I'm done as of this one. You have any questions? If you have any questions, please go ahead. Yes, you need, see, you don't need this report file. All the data files that are available. Why don't you load the data file and create the relationship? Okay. Again, we'll discuss, what are the other alternative ways of creating the relationship in tomorrow's session. We'll take a deep dive. Okay. Right. Any questions? Any questions so far? Okay. Since you don't have any questions, I'm going to wrap up the session. Kamaljit, I will review your code and I'll come back to you. Okay. Give me some time.